Okay, here we go. Solution of problem Jacobs chapter 4 or 17. This has to do with schedule crashing. Any point that you want to speed up this video, I find that I can usually watch YouTube videos at about 1.5x, just because I think you can some people can understand the YouTube faster. Some types of YouTube videos are more conducive to doing that. But anyways, you can check that out. See if you click the gear at the bottom of YouTube, it allows you to change the speed here. And the example that I have is set at 1.5 times normal rate. Okay, so we'll dive into the problem. We get a network. Okay, so this is the third type of problem that we're going to see regarding critical path. The first ones were very simple. We had to find the critical path through the system. The second set had to do with 3 time estimates, and we went all the way through how to look at the probability that it takes any particular number of days or weeks for the project to finish. The third set that we're looking at is how to crash the network or crash the schedule and spend some money to reduce it week by week by week. Okay, so when we have this kind of network, we're going to run through this really quickly here. What we're going to do is, if we analyze this through our normal technique, we start at week 0, add 5 weeks, A gets finished at 5, we carry that 5 forward, that's the early start for the next B and C. At the 5th week plus 10 more weeks, this ends, the early finish is 15, we can move 15 to the next activity. We're going to come back and take care of this C here. So it started at week 5 plus 8 weeks it takes to do that, 13, we end at week 13 on that. And we carry that week 13 forward on the next activities. Okay, so 15 weeks plus the 6 that it takes for D, we're going to come out with 21. 13 plus the 7 means this is going to finish at 20. And 13 weeks plus 4 says this is going to finish at week 17. So we have 3 paths by the time we get here we can see that are going to end up at G. We can see the longest path so far is up through D, so we're going to move that over here. That's the way it works. 21 plus 4 weeks is 25 weeks. So we've established that the critical path is through the northern route here. Okay, so the rest of the way that this works, we know that the critical path is A, B, D, G, and we know it takes 25 weeks. So we go on to the next part of the problem here. What we're really looking for is shortening up the entire project by 3 weeks. Okay, so let me take a quick screenshot of this. We want to bring this forward. Okay, I want to use this going forward. Grab that. Go to the next page, Control V. Okay, I just wanted to have an image of our analyzed network here. Okay, so this is the way it works. This is the table that you have to focus on here. In this table we have the normal time. We've been dealing with this all along. There's usually been a normal time or a nominal time, and in this type of the problem, we don't do anything that had to do with the 3 time estimates. This is completely different. Okay, so this is another skill to put in your quiver, to take to your interviews and take to your jobs. Okay, now a lot of this should be somewhat logical. You could probably do this in things that arise in your own life from day to day, and then we're just slightly formalizing it here. So the logic of this, hopefully you'll be able to just kind of track this. Let me bring this out a little bit so it's larger. Okay, this column for normal time is related to what we call the crash time. Okay, the crash time is how absolutely short we can make that activity. The nominal time is 5 weeks, and if we spend some money, we'd be able to remove 2 weeks out of that particular activity schedule and get it down to 3 weeks. The normal cost, this is different, we haven't seen this before, this is newly introduced to us here. The normal cost is $7,000 to do it in 5 weeks, and it relates to the crash cost of $13,000. So it takes $7,000 to do it in 5 weeks, or we have to add $6,000 to get it done in 3 weeks. Okay, so the $13,000 is for the entire process to take place in 3 weeks. So if we do that calculation, okay, let's create a little table here. So A, we're saying, let's look at how many weeks we can shorten this by. We can go from 5 down to 3, so we can save 2 weeks, okay? And the cost savings in that is 13,000 minus 7,000 is equal to $6,000. So if we can reduce it by 2 weeks, 1 week at a time, And it takes $6,000 to do that. I'll move that a little bit out of the way here. Maybe I need to make that a little bit smaller. Okay. Go. All right, so it takes $6,000 to reduce it for 2 weeks. The logic there is $6,000 for 2 weeks is $3,000 per week. Okay, that's all we're going to do. We're going to calculate that through for this entire table. So I'm going to do this. I recommend you get a pen and pencil and not watch what I'm doing here, and just make sure you can go through this. It's everything has to do with doing it yourself, is actually owning this process. Okay, so you should run through this and then check it with my final answers here. Okay, so now we have that full table. We have 2 weeks available. These are the important parts to remember. We can remove a total of 2 weeks from A. You'll notice that we can reduce B by 3 weeks. But all the rest of the activities, there's only a week available. The maximum we can reduce any of the other ones is by 1 week. So sometimes your processes can accommodate more change than others. When we calculated it out, A costs $3,000 per week, B is $2,000, C is $2,000 per week, and then we can see the rest of the numbers down here. We have a difference. We have $1,000 per week, $3,000 per week, $1,000 per week, $2,000 per week. So each of the processes have a cost associated with every week that you can reduce from there, and most of the processes you can only reduce it by 1 week. Okay, so let's continue with analysis over here. Let's come down here. And what we need to do is use that diagram. I want to just reproduce that in here really quickly. Okay. And the other thing I'm going to do is clean up our table there. From handwriting, I'm going to use an Excel spreadsheet that I have here. It's the exact same information, only all cleaned up. copy that over to here and Control V. All right. So this is all cleaned up. This is the Excel table all cleaned up, and over here on this page, it's this data put into a nice clean table so you can read it, okay? And the abbreviations for normal time is NT, normal cost, NC, crash time, CT, crash cost, CC. The book uses equations. I'm avoiding those in here, but you should be able to take a look at the equations and understand how we plugged in the numbers. When I calculated all this, this is using the equations out of the book. Okay, I think it's less confusing to just go ahead and do it. I think you can understand the logic much better than trying to understand what they're trying to say with the equations. Okay, so now how do we handle this? We know that our critical path is up through the northern route here. It's a total of 25 weeks. Okay, and so we need to shorten the overall length of 25 weeks by 1 week. It doesn't pay to reduce any of C, E, or F. We don't want to reduce them first and pay for something that has no effect, because if we shorten these up, they're already shorter, and that doesn't affect the overall time it takes to get through the network. So we're going to look along A, B, D, and G. I have them highlighted here. A, B, D, and G is the critical path. Okay, and what we need to do is find out where the cheapest place to reduce a week by. Okay, so we had calculated it. Here's 3 and 2 and 2 and 1 and 3 and 1 and 2. These are the costs that we just calculated right here as dollars per week. And of A and B, A is 3,000, B is 2,000. B looks like a better deal. It only costs us 2,000 to shorten that by a week. Continuing down below, we see that D only costs $1,000 per week, and G is $2,000. So it's clear that at D, if you remember, the only number of weeks available for D, though, is only 1 week. It's cheap, but there's only one option there, okay? So what we end up doing is we change this to, it only takes 5 weeks. This comes out at 20 weeks. We enter here at 20 weeks. Notice that now these two paths are both critical. These two paths have the same amount of time through, okay? So notice that. So activity G can start now at week 20, and it can finish at 24. We're trying to get down to 22 weeks here. Okay, so now we have to go back and we have to analyze where to get the next week from. So what I'm going to do is draw 3 columns here, and week 1 and week 2 and week 3. Where do they come from? Okay, so we took week D to begin with. I'm sorry, activity D for $1,000. We have to find the next cheapest option. We can't go back to D. We used up the only one we had available. It's gone now, okay? So if you think about what's going on here, if we reduce the critical paths at A or G, we'd only have to reduce one activity at a time. So right out of analysis here, we can say probably the next place to reduce time is A or G, because if you get up into these activities here, if you reduce one of these two activities, and this should go to 19, if you make this 19 now, you still have 20 here. This is still the long pole in the tent. It's still the limit. We'd have to bring both of these paths down to 19 by this point. That means you would have to buy, and I'm going to get rid of those because we're not going to use them. Okay? You would end up having to remove a week out of B. You can't do it out of D anymore. And you'd have to remove a week out of C or E because they're parallel. And you'd have to get both of these down to 19 somewhere within this area. So B would cost us, if we go to the table, $2,000, okay? And we reduce that by 1 week. And which is cheaper, C or E? We come in here, we look at C, is 2,000, and E is 3,000. So you would reduce this by 1 week, and it would cost us 2,000 again, all right? So the total cost to reduce both of these paths by a week would be $4,000, right? But if we look at A and G, G is only $2,000. So the next place we would reduce would be at G. We get what we want out of this whole thing. Costs us $2,000, and we go to 23 weeks. We still enter at week 20, but we've reduced the length of this from 4 to 3 weeks, and we also expired the only week we have available to us. So where do we get rid of week 3? Now at week 3, if you look at the same argument holds, is now we're either going to reduce A alone, or you're going to have to reduce B and C, or you're going to have to reduce B and E, okay, as an alternative. So you're going to reduce, it's going to cost us $3,000 if we reduce at A. There's the dollars per week is $3,000 there. And we have the same argument as we had before, that it would cost us B and C. It would cost us $2,000. It would cost us $4,000. So reducing A is the cheapest option, and that's your solution. How many dollars did it take? Well, we achieved the goal. We went down to 22 weeks, okay? And the way that we did that is we chopped this down to 4, and that 4 would ripple through everywhere here, and we'd end up with 22. I'm not going to go ahead and do that. It's already kind of messy. The way that this online pad is, that the way that it works. So the total cost would be $1,000, $2,000, $3,000. 1 and 2 and 3 is $6,000. That's how you would do it. And you would have used D, G, and A. That's the solution. You should be able to find that solution, that type of solution for your homework problems.